All right, we're going to talk about multiplying and dividing radical expressions. So if the nth root of a and the nth root of b are real numbers, then the nth root of a times the nth root of b equals the nth root of ab. Now, one of the big things that you have to understand when you're multiplying or dividing is that you have to have the same index. Okay, so if the indexes are different, there's nothing you can do. It's in simplest form. So on our first example, we have the cube root of 6 times the square root of 2. Notice my indexes are different. This can't be multiplied. Okay? It is in simplest form. Okay, so that's the simplest form. Now the bottom one, I have the cube root of 4 times the cube root of 2, so I can go the cube root of negative 4 times 2, which is the cube root of negative 8. Well, what's cube root of negative 8? Negative 2, so there's my answer. Okay? So understand that when you're multiplying these out, you can only multiply out if they have the same index. We're going to talk a little bit about simplifying here now. So when we're simplifying, we're going to simplify in pieces. So this is the cube root of 54 times x to the 5th. Okay? So I'm going to talk about kind of like how the book does it, and then I'll kind of talk about maybe a little bit another approach that is basically identical to the book. The first thing is we need to break up 54 because we want an exact value. So we don't want to have this be a decimal of, 4 point or 3.8962. We want this to be exact. So there might be pieces left inside the radical. So I need to understand what values I know the cube root of. So I know the cube root of 8, right? Cube root of 8 was 2. We just looked at that. Well, 8 is not a factor of 54. So I'm going to go to the next one. Well, the next cube root I know is 27. 27, well, look at that. 27 is a factor of it. So what I'm going to do is I'm going to break up 54 into 27 times 2. And then I'm going to break up this x to the 5th into groupings of cubes. So I'm going to say, well, I'm going to go x cubed times x squared. All right? Now, I know the cube root of 27. The cube root of 27 is 3. I know the cube root of x cubed. It is x. And then I'm going to leave everything else inside. So the 2x squared. Okay? So I'm going to talk briefly about how do I know what comes in and what comes out. How do I know it's just an x outside and an x squared inside? Well, think of it like this. If I look at, I go old school and go back to elementary math, if I go 3 divided by 5, well, how many times does 3 go into 5? Once. And so that's how many x's go on the outside. What's my remainder? 2. That's my power in the inside. Okay, so my whole units is how many x's I have on the outside. My remainder is my power on the inside, so you can kind of do it that approach too. Example 3 here says, hey, I have this product of these 2 square roots. And we want to look at how do I break this up. Now, a lot of times, you can do this in a variety of different ways. Okay, so one of the ways is, I'm going to multiply everything out here. And I'm going to get the square root of 720 x to the 4th, y to the 5th. Okay, well that's nice because I can now see I can break some of this up. That's not too bad. I can do some stuff in there. The problem with multiplying these out like this is it makes the constant, it makes that coefficient here larger. And so sometimes that's problematic to find the square root. It actually really helps with your variables because then I can go, okay, well, the square root of x to the 4th is x squared. The square root of y to the 5th is y squared. And I know I have a y to the 1st inside. I don't really write the 1 there. But now I got to look at breaking this 72 up. And that's where it becomes a little bit harder. And so if I break that up, I might break that up into items where I go, well, I know 36 goes into 720, so I'm going to break this up into the square root of 36 times 20. And 20 has a square root I know. So 36 times 4 times the square root of 5. Well, the square root of 36 is 6. The square root of 4 is 2. So 6 times 2 is 12. And then that becomes the fifth root. Now, personally, I like to go ahead and simplify the radicals first because it's just easier for me. Does it matter? No. If this is easier for you, then absolutely do this. Okay? So a lot of times I will look at this and go, oh, okay, I'm going to break 72 up into the square root of 36 times the square root of 2. And then this becomes the square root of x cubed, the square root of y squared, times the square root of 2, times the square root of 5, times the square root of x, times the square root of y cubed. Well, I know the square root of 36. It's 6. I have the square root of 2 times the square root of 2, which gives me square root of 2 times square root of 2 is 2. Okay. I have x cubed and x, so that's going to give me x squared. Here I have a y and a y, so that's going to give me y squared times the square root of 5y. Okay, so this gives me 12x squared y squared, square root of 5y. Doesn't really matter. You're going to get to the same point. There's a lot of different ways you can do this. You just got to find what works for you. Okay? Now, if the nth root of a and the nth root of b are real numbers and b does not equal 0, then the nth root of a divided by the nth root of b is the nth root of a over b. One of the things I should have said about this multiplication and division is it works both ways. So I can work it from being separated into 1, or I can take 1 and separate it out. So here, I have the square root. Now, I could take the square root of the top and work it all out and get that piece, and I can take the square root of the bottom and work that piece. Or I could say, you know what? They're both the square root, so I'm going to do this. I'm going to put these together here. Well, now I'm going to divide. 18 divided by 2 is 9. X to the fifth divided by x cubed is x squared. Now I can take the square root. The square root of 9 is 3. The square root of x squared is x. I probably should put an absolute value around it. Okay? Because we typically want that positive side. Now, here's our next one. So a lot of times we want to get these simpler. So we're going to do that same format here. Y to the fifth over 3y squared. This gives me the cube root. So I'm going to divide this. 3 goes into 162, 54 times. Y cubed. Well, earlier we did the cube root of 54. We found that it was 3. Okay, so if I look here, the cube root of 54 is going to equal the cube root of 27 times the cube root of 2. Right? So the cube root of 27 is 3, so this becomes 3 cube roots of 2. There's my 3. I'm going to look at my variable because I know I have the cube root of 2 here. Look at my variable. The cube root of y cubed is y. I don't have any remainder, so there's my answer. Okay. Last thing we're going to talk about is rationalizing the denominator. If I have a radical in the denominator, I don't want to leave it there. I want to get it to the top. Okay. So what I'm going to do is I'm going to multiply by top and bottom by the same number, and that number is how to get rid of this radical. Okay. So square roots. I'm going to multiply the top and bottom by the square root of 2 here. And so I would have 5 square roots of 2 over 2. Now, if this changed, okay, so let's say I now don't have the square root of 2. Let's say I have the cube root of 2. Okay, well, I only have 1, 2 here. So I need to make this be 2 cubed. Okay, so whatever my index is, I have to have a multiple of that in my denominator. So what I'm going to do is I'm going to multiply top and bottom by the cube root of 2 squared. Okay? And so now the cube root of 2 times the cube root of 2 squared is going to give me the cube root of 2 cubed, 5 times the cube root of 2 squared. Well, that gives me 2, 5 times the cube root of 4. A lot of times, personally, I will leave this with powers in here so I can see those multiples. Okay? So here now I have this one here. So I now have the cube root of 5x squared over the cube root of 2y squared z. So I need to multiply that by something. Well, I have the cube root of 2, so I need to multiply that by the cube root of 2 squared. Alright? I have 1y here. Okay? So now to make this 3y's, I have to have one more y in there. Alright? And then I have 1z. So I need that to be 3, so this will be z squared. And now I'm going to multiply this out. So on the bottom, I get this. I get 2y squared, 2yz, because will have y cubed. The cube root of y cubed is y. I have the cube root of z cubed is z. I have the cube root of 2 cubed is 2. And now I'm going to multiply out this top. So 2 squared is 4. 4 times 5 is the cube root of 20. X squared, y, z squared. I now look to see if I can simplify that 20. Is there something that multiplies, that is a factor of 20 that I know the cube root of? Well, I know the cube root of 8. 8 is not a factor of 20. The next one I know is 27. It's too big. There's my final answer. So that's rationalizing. So that's kind of talking about multiplying and dividing radicals.